Oof. Okay. Cool. All right. User defined types. I need to think. I don't really want the music right now. All right. So we were here. Two different categories of compound types. Really? So there are enumerated, and then there are class types. So classes like. When I think of a class, I think of an object or a class is a structure from which an instance can be generated, the components of which include other fundamental types or other classes. So I create one that has an integer and a boolean and a who's a what's it, and a who's a what's it is another struct that includes another integer. So it's really like an int, a bool, and another int. But an enumeration, I don't know. An enumerated types? I've never heard this word before. Besides, outside of the context of Unreal Engine or programming. No idea what it is. Scoped and unscoped? Meaning like global versus something else? Because it seems like global is almost unscoped because it's in scope everywhere. As long as it's declared somewhere. Defining program type or program defined types. So scoped would be like including it within a given scope, but unscoped would it be everywhere? Or I think so. Program defined types. And I guess we say program because if it's not defined specifically in the just like them, it must be defined and given a name before they can be used. Yeah, makes sense. We can't put it later and then use it earlier. Yeah. Like, yeah. Type definition. The definition for a program defined type is a type definition. It must have a name and a definition. It can't just exist as the components without a name, nor can it just be a name without components. The other component types, or the other compound types, require neither? Really? It doesn't require a name? Hold. The other compound types, like a pointer. So I guess meaning that a pointer to something doesn't need to be created itself because I can just get the address of it, maybe is what it's saying. Versus and like passing something as an address because it can be received as an address. I don't explicitly have to make a reference, not an address. I don't have to make a reference to something to then pass the thing by reference. I can just do it. What about a function? I guess it doesn't necessarily have to be defined in the file, huh? That's the point. It needs to be defined elsewhere to be used, but does it need a name? I feel like functions need names, don't they? Void. Oh, I guess there is such a thing called unnamed function, though. I don't know how that would work. Unless it's some sort of overloading thing where you just pass in the arguments and there's no other function that exists with those arguments. Or maybe the point is that there's no other unnamed function that exists that takes those arguments. Functions aren't considered user-defined types, even though they require. Okay, well they do require a name, and they need to be defined somewhere. Makes sense, because the function itself. So a function is a type. Oh, gotcha. Meaning that the type itself, like void do thing int, is of type void do void int, and I don't have to define void int somewhere. I think is the point. So the function itself can be named, yeah, like the object, but the function's type doesn't have to get a name or be defined anywhere extra. We just make a name for the function type. Okay. Functions that we define ourselves are user-defined functions. Okay, as opposed to core functions or header functions. Definition of a custom fraction type and an instantiation of an object. So we define a program-defined type named fraction. Yep, that way the compiler doesn't bitch at us. We'll explain what a struct is and how to use them later. What a fraction type looks like, it doesn't create one. But then that creates one. So struct fraction. Okay, so is there anything else where we have to put a colon after the, or a semicolon after the brace? The only thing I can think of is a while loop, or a do while loop, because it's do this end brace while this semicolon. But a for loop doesn't need one at the end, nothing else needs one. Okay, so it's like I mean, I guess you could almost say that it looks like struct fraction open brace in this close brace semicolon. So it's almost like we're defining. So we're defining integers on their own state, on their own as their own statements. But the struct type definition itself is also a statement. It's like a complex statement, kind of, but it actually, the end of the brace is the end of the whole thing. Okay. Oh yeah, I need an alarm. So an hour and 20 more minutes. We'll say. Okie doke. In this example, we use struct to create a new program-defined type named fraction. In the global scope, it's not in a namespace, it's not in the function, but I guess it probably maybe is like a function where it can't be defined in a function, maybe. This doesn't allocate any memory because we haven't actually created any, it's just in the code. Because the compiler holds it, and the compiler would do the creating. So sure, this would be instanced at one time or instantiated at runtime. Therefore, the definition, just like writing down a function, doesn't use any memory. Okay. God, the way that this is all converted down into zeros and ones, holy shit, man. This does not feel like a low-level language at all. I mean, is C++ low level? Oh, it's mid, okay. Bro. Examples. What the fuck? Machine assembly? Really? That's it? Okay. Dude, this is crazy how much better it is. Imagine writing an assembly. Fuck. Then inside main, we instantiate and initialize variable type fraction named f. Program defined type definitions must end in a semicolon. Okay. Gotcha. Makes sense. And then we're seeing, oh, what's the issue with main? What? End them in a semicolon. What? Oh, here we go. Oh shit, I learned about enumerations here. Okay. So what the fuck are we gonna do if we're not using structs yet? Excuse me. Naming program defined types. Capital letter, so just like a namespace. Okay. No suffix. Oh, gotcha, because we have fraction as the type and fraction is this instead of like naming fraction better. No different than any other. I mean, yeah, it'd be the same as int1. So in this case, maybe you'd want fraction 1 or my fraction or fraction this or something important or I don't know. Oh, this is cool because we could have a struct and I could update the struct in a function and return the struct and use it just as a means of returning multiple values. Instead of doing reference parameters or, yeah. Or our pointer parameters. In, out, or out parameters. Fraction comes first. It's program defined type because it's capitalized. And then fraction. And then an optional initializer, okay? We don't have to necessarily initialize it. I wonder what happens if we just pass it one thing. Does it just initialize the first thing? I don't know. Using them, every code file needs to see the definition. Makes sense. A for declaration is not sufficient. So what, we do some header file action? Yep. KO. Every code file needs to see the full type definition. For declaration is not cool, bro. Compiler needs to know how much memory to allocate for objects. Gotcha. Because the compiler only looks file to file, and it needs to see all the shit. Just like if a function was being defined inline, just like if it was a const expression function where it needs to know all of what's going on in order to actually make it happen at compile time. Okay. Header files included into any code file that requires them. Fraction.h. Okay. In that code file as close to the first point of use as possible. So like right before main if it's used in main, unless you can define it within a function? I don't think so. A program defined type used in multiple code files should be defined in a header file, same name as the program defined type, and included in each code file as needed. Okay. Excuse me, struct. Structure. KO. Only including it if the header guard hasn't already been included and defined. Yep, this is the type definition. And it includes all the stuff. Wonder, can we just initialize them with specific values? Then change them? I guess so, huh? It's default spawns with this much. Oh, like item. And an item spawns with durability 100 by default. But when you're actually spawning items in the ruined, crumbling city, maybe you cap it so that they can only spawn at 37 or lower. And then you use a Mersenne twister so that they spawn with the proper values. KO. This is cool. I'm seeing how these things are coming together. This is going to be fun to make a game pretty soon here. It's like a little test game. It'll take probably a long while. I don't know. I have no idea how long it'll take. I want to make a copy kind of this game. Nice. 4,000 people still. Good, good, good. Damn, shit's cheap. I need whatever I'll talk about later. But I think I'll have a struct for each player. So then each player has a hand, and the hand has 5 cards, because I don't know arrays now, so I can't just have one variable with the cards. I'll just have card 1, 2, 3, 4, 5. And then there'll be either numbers or standard strings. Probably standard strings, and I'll just pass references. That way I can make the game as accurate as possible, where like each card is actually a king or a queen or a jack or whatever. We don't care about the suit, just the face, I guess is what it is called, right? Type of card. The value. We include fraction. Cool. So we get the full type definition in there. Main fraction f, and it has a numerator of 3 and a denominator of 4. Cool. And then we could have a member function later on that is, we could just do dot print, and it prints numerator and line, or numerator, maybe numerator slash denominator, probably 3/4 instead of having to do a whole end line. You could do that. You could do 3 end line slash end line slash, or 3 end line slash, or like minus, or something like that, -4, but probably 3/4 is better. And then I could call and print. Okay. Just actually creates it. Numerator 3, denominator 4. Okay. Ooh, type definitions are oh yeah, types and templates, right? Is it because they're implicitly kind of in line? Partially, though, is interesting. Okay. Should I go ahead and use one? What would I want to make? Sure. Struct monster. Oh, and it automatically put the semicolon. That's nice. Excuse me. Struct monster, and it has a const standard string name. Oh shit, and I can make different ones. And I can make them global. I can make the definition and then have a global one, or in a namespace the existing monsters. Ooh, to have different ones. Okay. It has a name. It has a const expression int max health. It has an int current health. What is happening? It can't be const expression? Okay, never mind. It can have const. Okay. What else can it have? Yeah, I guess it's because we can't actually make them until, not sure. No const expression. All right. Is that it has a const int damage, and then I could make a monster named orc, and it has a name of, oh fuck, I would need, isn't there, include suffix? Fuck, what is it called? Suffix string. Damn. I don't know. I mean, maybe I could convert it. Orc. Okay, we didn't get an extra error. Oh shit, hold. And it doesn't care about a comma here? Okay. Now what happens if I... Uh-oh. Doesn't take it? Nope. Because we would need to get .name. Oh, shit. .name? Oh, okay. And now orc.maxHealth is now... Oh, well, it's already created it. It's initialized. So let's do 100. Fuck. I can't initialize... I mean... I guess I'd have to organize it in a way where the... I guess that's probably just a smart thing, right? Or a more intelligent thing. Put the costs first. So we say, okay, max health is 100. The damage is 30, or we'll say 65. And current health is... sure, whatever. We don't even need it right now. Okay. And we'll say orc.current health is 100 as well. And then we could say orc.name name. Well, let's see. Max health. Orc.max health. Orc.name damage. Orc.damage. Oh, well, I guess I could do either, but whatever. Sure, we'll do. Orc.name. Oops. .name. Current health. Orc.current health. Oh shit. Alright. It's cool. And then I could set... We could call... We could say there's... I guess we could say later. Sure. Namespace. Oh shit. Well, player, we could just say... I could have another struct that's the player. But we could say... Oh. Could I do... Can I get a reference? Can I get a reference to it? Oh. Oh. Oh shit. I can. Reference. Yes. Reference. Yes. Reference. Yes. I think, because I don't want to copy these. Or maybe that's fine. Maybe it's not actually being copied anywhere, so it's probably okay. If I'm assigning something it to avoid copying it, then maybe that's when I do that. Maybe not though. Maybe it's just when I pass it to a function, actually. I think otherwise it kind of seems like maybe overkill. We'll say namespace player, and we'll just say it's a const standard string, player name, and it's Ethan. Sure. And then we can say void apply damage standard string, a reference to a standard string. This way we can pass it cheap. Damager, or we'll say attacker, standard string, target. And we'll say, oh, and then we'll say const int reference damage. Attacker, well, and this could just be a standard string view, honestly. Well, these are all standard strings, so it's actually fine. Attacker deals, excuse me again, this damage to target. Okay, and then we could call apply damage. Attacker is, and it's received as a reference, that's fine. Player name. The receiver is orc, and the damage is constant reference. This could just be a const standard string reference, so no changes. And sure, we'll just say 30 this time. Hold. From monster to standard string, hold. 29, what's the issue here? Oh, orc.name. Let's go. Wowzer. Okay. And then we could say, oh, maybe we don't want this to be a standard string. Maybe we say now. We could, I like the change here. This isn't bad. Target.health. Hold. Uh-oh. How do we do that? How do I... oh, no. Here's where the casting stuff happens. How do we... right here, it just looks like a standard string. How do I get the owner of that standard string? I would have to pass in... oh, I guess this would probably be the easiest way, huh? We could just pass in who's actually getting attacked. So we could just say orc, and this would be a monster reference, and that's it. Target. And then in this case, to target.name. And then we could say target, because target is a monster, it has a dot current health minus equals damage. And then I could print the properties again. So we could just say, let's just say void print monster properties, or print monster info. And it simply takes a monster reference, a const monster reference called this monster. And we could say this monster name, excuse me, instead of orc, instead of orc, instead of orc, instead of orc, instead of orc. So this is referring to it and printing the info from there. And then we could say print monster info and pass it orc. And then I could do it again. Okay, so create and print orc's info. Player attacks orc. Print orc's info. hold. And maybe after we attack, we do this twice. Maybe. Maybe this is overkill. Sure, let's try that. All right. Everything is still cool. Cool. But we could say print monster info and then what we want to print, maybe. Oh. Shoulder's still kind of whack. I don't know how I freaking pulled it that one day. Okay. I want to print what I want to print. So, I mean, it might just be easiest to output just the health. But what if I wanted to print a bunch of shit? A reference to the monster, and then... So that prints everything. I mean, it can have different member functions maybe that print monster info. Could I try this just to see what happens? Ooh. Excuse me. Okay, so we could do that too. We could do like get health and set health stuff. This stuff's interesting. I don't know if I want to go too much further though. I might be developing bad practices here, but that was cool. I can now have an object and I can make functions inside it to get it its own info instead of having to pass shit to it. Because it's like a fucking class where the object has its own little bound kind of function. That is cool. Let me... I think I need to like stretch a little or something while I'm doing this. So... Oh, well now it's fucking hard to read if I'm tilting. Include the fraction definition? Ah, but then I'm gonna have to fucking read like... Actually, I think this is okay, because I can just put them like this, huh? Include the fraction, or include the definition of this struct. Now we can make use of our fraction type. It's a fraction object named f, yes, because we have fraction f, giving it a numerator of 3 and a denominator of 4. Type definitions are partially exempt from the ODR. Yeah. Oh. Oh, that's good. Discussed how the one definition rule requires each function and global variable, only have one definition per program. It sounds like this is just talking about inline stuff, dude. Because inline just means that the linker is going to deduplicate it up. I mean, this assumes that structs are not implicitly, or sorry, this assumes that structs are one, implicitly inline, and two, have external linkage, which it seems like they probably do. It seems like they're probably like templates in that for instances to be generated, they... Should I do my regular stretching? I guess so. For instances to be generated, they must be known. The compiler must know them and see them anywhere they're actually used, huh? Probably makes sense. Alright. Requires each function and global variable only have one definition per program. Hold on. I need my fan. Fuck it. I'll just take it up there. Yeah. Feels like it's... Oh, yeah, it is a long weekend. That's why. Forgot. Say, because I haven't... Kind of tight. Stretch out a little. I normally do this only on weekdays at work. Once a day, usually. Okay. One definition row requires one definition per program. Cool. Yep. You have to forward declare them. Yep. Problem is that here, just like for templates, forward declaration is not sufficient to satisfy the compiler. Compiler needs to see it all, just like for an inline function, just like a const expression variable, just like a template function, or a function template, I guess. Gotcha. Partially exempt. That is, a type can be defined in multiple code files. Same shit with, sounds like inline. Oh, so it's not that IOStream actually has a header guard in it, preventing the types from being defined. It's that it's actually okay. It's included in one file, and we don't want the rest of or it's included in one header file, maybe, and we include that header file elsewhere, and we don't want multiple because our header file doesn't have types. So we would we would violate the ODR, the one definition rule, if we included our header file into multiple CPP files. But we can include IOStream into as many as we want, and it's not because it has a header guard that protects us. It's because types themselves require definition everywhere they're used. So we actually need that code everywhere. So it's fine that an in and output stream are defined in one file, which is included in another, which is done there, and that's fine. So we have a math.cpp file where it's two integer parameter, well, it's a void function that takes two integers that just outputs the quotient of the integers. And it needs the definition of the O and I streams, input and output streams. In that case, just the output stream. And so does our main file. It just so happens that when we include it into one file, into one header file, and we include that header file into two files, then it's cool. The code that's been already included in one is not, well, let's see. If I include... Well, yeah, I guess I only do that for stuff that's inline for my own files. So, yeah, because I would have like a math.cpp to actually have my math implementation. Okay, yeah, makes sense. Cool. Two caveats. Only one definition per code file makes sense, otherwise the compiler is going to complain. Okay. Which is cool. Because if I include a file that's including IOStream in it, or if I'm including two files in this one and both already include IOStream, well, I get both of those files, but I would get IOStream twice, but I don't because the second that it's defined the first time, I don't get the IOStream parts in the rest. The compiler would see, hey, header file 1 with IOStream, okay. Header file 2 with IOStream, oh, ditch that IOStream, don't include that part. They must be identical, yeah, because if I have a type in one spot and a type in another spot, and one of the definitions for fraction is numerator denominator, and another is some complex crazy shit, like I don't know, a fucking binary fraction, whatever that looks like, to show you how they're actually represented, how floating point values are represented, then it would be not good, it wouldn't know. Let's see what happens, I'm curious. Alright, let's just say struct thing int thing. Okay. Sure. Uh-oh. Okay, we're fine. Oh. It's okay. The problem is maybe just when I use the thing. We have a bool in one and an int in another. Do I need a namespace that uses it? Sure. So far it's okay. Linker doesn't care. Oops. Excuse me. Must be identical, otherwise undefined behavior. Okay. Well, and I guess the point is that we include the types in a header file anyways. Well, yeah, and if I'm passing like a header file, or sorry, if I'm passing a reference of a struct in one, or a type in one file to another, yeah, let's fuck it up real quick. Hold on. Let's say a car has, sure, let's just say it's an integer and it's color. Okay? But then we have another, and it is car, and it has a struct car, and it has a bool, and it's called four door, or four door. If it's a four door or not. But then we have void get car info outside here, and we say, we pass in a reference to, or a car reference, car, and we include IOStream here. Car.4door. And we'll do standard bool alpha. Okay, and now hold. For declared here. Defined there. It's realizing that this is a different car than the other. What if we did this? We replaced it, and we simply said color. Oh, well, in this case, we don't need standard bool alpha. Uh-oh. Oh, well, it doesn't know what car is in this case. Duh. Okay, that makes sense. All right, so we'll leave it like this now. Hold. Oh wait, hold on. This is just a for declaration, bunch of unidentified guys here. Oh. Uh-oh. Oh wait, hold on. Uh-oh. Uh-oh. Oh shit. It's outputting true because it's seeing that, but if I did this, then it would be false because it's operating. This is the function operating on this car. Okay, interesting. Because right now this doesn't give a shit about this. I mean, well, it does. It's trying to use for door, and it just so happens that this value can be implicitly converted to a Boolean via numeric conversion. Okay, don't do that. Make the definitions identical. Now, user defined versus program defined. User defined, as well as being mentioned in the C++ language. Casual. A type defined within your own programs, like fraction. Okay, it's a user-defined type. In the standard, it says it as any class type or enumerated type that is defined by you, the standard library, or the implementation. Meaning that a type that the program is aware of, not necessarily one the user made, because standard character output is technically a user-defined type. You sure? I didn't make that, buddy. I did not make that. Excuse me. C++ standard helpfully says program defined type to mean class types and enumerated that are not defined as part of the standard template, standard library, implementation, or core language. In other words, program defined is basically the user defined. That's what it means. Or hold it. A program defined type is that is defined in the program, not the standard library, not the implementation, meaning your architecture and shit, nor the core language. So really, user defined, we're using program defined or program defined instead of user defined because the C++ standard says user defined in the wrong way. It should be flipped. It should say, well, no, I guess program defined is actually right because program means this. User defined means made by people, a type, really. Program defined types include class types and enums, and enum types, enumerator types, and defined by us or a third party library. Okay. Yes. So we will say program defined by us or by another thing that we're including. So we have fundamental, basic types. Compound types are those that are defined in terms of other types, like standard string. Nice. Good. I thought that it might be. And I guess it's because it's a struct or it's a class or something like that. Like fraction. User defined are a class or enumerated, and that includes the standard library implementation, etc. And then program defined are a class or enum type that we probably made. Or at least the shit that didn't come with the C++ that I can't just include straight up, probably. Unscoped enum, whatever the fuck an enum is. Let's find out. C++ contains many fundamental compound data types. Cool. Well, yeah, we got ints, and floats, and doubles, and longs, and long longs, and long doubles, and ints, and sure, and shorts, and bools, and fucking fasts, and quicks, or something like that. Oh, excuse me. Oh, excuse me again. Excuse me. Holy shit. These types aren't always sufficient for what we want to do. Keep track of whether. Boom, boom, boom. From a preset list of colors. I thought that, yeah, I thought like in from what I've seen in C++, I haven't really seen enums ever used. I think I've seen them but not had them broken down or anything, meaning that I would watch a video when I was learning Unreal a little, and I was watching other people's stuff because most of my time on Unreal was just me doing stuff. But when I would watch other people, I would see something and it would be, I think it would be yellow, or it would be whatever color matches the enum color. It's a specific color. And I don't know, it's like something multiple choice, like checking if something is a part of a category or something like that. It's different from something else, from classes, I guess. I'm not really sure. I don't know what the fuck's going on with it. Writing a program that needs to keep track of whether an apple is red, yellow, or green, or what color a shirt is. If only fundamental types are available, how would he do this? Yeah, meaning, okay, we're not using floats or fucking booleans or other shit. Okay. Well, we could say is green, is this or this, or whatever, and then we check. Or we could just say, hey, if this, it's green, if this, it's red, if this, it's that. Okay, so we say 0 is red, 1 is green, 2 is blue. Cool. All right. And we do that for a color too. Yeah, these are basically magic numbers because we don't know why the fuck they are. By using symbolic constants. Gotcha. Because we could say, okay, yeah, so when I'm writing the code and I'm saying, hey, I'm creating an int of this color, I can put in red. But we need to make sure that there's something that is red that corresponds to a value we can track. Yep, symbolic constants. Cool. We got some guys that exist at compile time. Red, green, blue, 0, 1, 2. Nice. And we still have to say, okay, it's a fucking integer. Using type alias, so we could say a color instead of an int. I don't know about that. I still don't like that because now we don't even know what the fuck a color is. Is it a standard string? Is it a... I have no idea. I mean, I could look in the file and see, sure. Yeah. Meaning that we could still make them... Apple color could be 48. This could be this. This could be this. There's no limit to what you can do. It's not like... I don't know. If you have... using universe equals restricted boolean. If we had a restricted boolean type, then we could have it be only true. That's all it can be. It's only true. That's it. Then we're restricting the value to only be that, and it can only be that. But right now, there's no issue with using other numbers. Yeah, exactly. Yeah, we have no idea what color that is. Yeah, because you would see it as C8. We wouldn't even see red, so it would be hard to distinguish good values and good usage from bad usage. Meaning that we create a struct, or not a struct, I guess, but we create a thing that only has these possible values. And we could make our own keywords that are right. So like, it's Attack on Titan, a game, and I create, a struct, okay? And the struct is the Titan, and it has a name and a this and a that, and that's that specific Titan that exists. But it also has a type, or a Titan type, we'll say, capital or lowercase. Yeah, sure. It has Titan type. That's an enum, and it can only be what is it? So I guess it's like a standard string, we could say, maybe, or it could be there's this class, or this class, or abnormal, something like that. And those are the only values that are proper. So if we put in 2, then it'll say, hey, that doesn't match the type. We can't convert 2 to type, whatever, something like that. If we had the ability to, and this is where we get our own user-defined types, so that we could do, so that implicit conversions could finally go down and try the implicit type before giving us an error. An error. And enumerations. It's also a compound type. And set of named symbolic constants. So an enumeration is the type and the values are restricted. Just like we could say Boolean could be an enumeration, with the enumerators being true and false. Unscoped and scoped. They're program defined, and they need to be defined everywhere before it can be used. So header file action here. Defined via the EO keyword. Oh shit. You can actually put in those unique words that become keywords, probably. Wonder how we restrict it. Do we put it within a namespace so that red, green, and blue are safe from name conflictions? Oh, I'm getting tired. I need music. That's what I need. KO. A comma. And it has a semicolon at the end too. Okay. Interesting. Wonder how it's printed. Does it disallow numbers? Oh, wow. Fuck. Yeah, I listened to that. That's for show. That's church, yo. Fuck. Doesn't like it. Yeah, because it thinks that's a suffix. Alright, now fuck that shit. Can't I... Yeah, okay. In,
Titan.
Oh, wait, on. Titan type. $12 meter. 20 meter. 10 meter. Sure, we could do that, huh? I wonder how it interprets these though. Are these just characters? It's an enum type. It's its own thing. So how does it print it? Does it just print it as a sequence of characters? Oh, how about Titan dot? No? How do I? Oh, I was trying something crazy. how do I get the info now? That's the question. Because the point is I could have a struct Titan. Hello? How did I go down? And it has a Titan type. Oh, and it's cool with that? It's cool even if it's after. Is it not? Yeah, it doesn't know what that is, I think. Oh wait, hold on. Titan type, type. Boom. And so I could make a Titan named Titan with a type 10 meter. Holy shit. And now print the Titan. It's not, there's nothing, we can't do it. Titan dot type? Still that, because we don't have. What do I have to do? Do I have to convert it to a standard string maybe? I don't know if it can convert though. It's not going to look at it and just say, hey, words to words, buddy. Maybe I have to define that. Hold. I did that wrong. Include string. Need standard string. We need that first. I don't think it's going to like it. Dang it, it's not happy. Yeah, there's no way to convert it. Ah! Dang it. I would need something that takes the literal text and converts it into the stuff. Yeah, I don't know how to do that. Damn it. I was cooking too. I mean, I could still use it to check stuff, right? So we could say if Titan or if Titan dot type is 10 meter, or what, we don't need this. So I could still do this. Oh. Can I define a function? I could say print type, and if it's this Titan type, get type. Oh, this is. Uh-oh. Oh, it doesn't like it. Oh no, it's not happy. Nope, it doesn't want it. Oh no. Oh, it doesn't like it at all. Nah, it doesn't want it. I was trying to see if I could make like a member function inside of this so that I could do Titan type dot something. I mean, I could do Titan dot print type, and I would say, excuse me, it would check the type, and then if it's this, it prints this. If it's this, it prints this. If it's this, it prints this. I mean, it's a way of doing it. All right, back to it so I can stop fucking myself up. It's very fun to play around with these things now. This is where the hours will come in. I can actually make shit. Ooh! And I could use an enum for the cards in my game. My little test game. So enum card, and card is either king, queen, this, that, or this. And we make a card, and it's either king, queen, jack, or Ace? I think that's it. Or Joker, maybe. I'm tripping. I was looking, my glasses like wiggled, and I thought that there was motion over there. It scared me. Tripping. Oh yeah, what do we get if we do an invalid? Oh, so it does convert that way. Oh. Oh wait, hold. Not, so it's false. Is 1, 0, or 2? Oh. And so maybe this is the 0 enum, the 1, or the enumerations. Enumeration 0, enumeration 1, enumeration 2. Now what if we do that? What if we do that? Or what if we do that? Does it choose the second enum? No, good, okay. It cannot be used. Cool, and we don't have to do const expression this is this or whatever. Nice. Comma. Trailing comma optional, but recommended, so I can just add another maybe. Okay. Alright, let's do one for cards. I do main just to not see that linker error. Cool. Unscoped. Okay. And I guess we treat it the same as before with a struct, where it must be defined everywhere. And the linker will say, hey, we're cool. We're cool. Inline, baby. Deduplicate. Or at least, I mean, inline seems like it's exempt, making things exempt from the ODR. So I'm going to say exempt equals exempt from ODR, inline equals exempt from ODR. Which is why I'm calling them inline. I'll be corrected later, probably. We have a color enum, yes, with 3 enumerators. Got the enums for enumerators rather for the color red, green, blue. Cool. Now, when your leg falls asleep, you can pop your toes without it hurting. That's the strat. Each enumerator must be separated by a comma, yes, and the trailing is recommended for consistency. Okay, so we can just add another one later on. Yeah, just like having a break or a return after the last case. or I guess break is probably more accurate, but a break after the last case in a switch, even though it's already going to end after that. Or at least after the shit has ended, after the last case's logic has ended, the default case, then boom. What happens if we do default and then a case after? I've never tried that. Oh, it's okay with it? Really? So what if it's 1? Oh, so it actually checks. So the default doesn't have to be after. Oh, what is it saying here? Unannotated falter? Oh, well, oh, wait, hold on. Oh, well, yeah, that's why it's doing that. Okay, yeah. Yo. Yeah, chill out, bro. There's no error. The point is that you normally have default at the end. Okay. And the point is you put break at the end of it too. Even though in that case I wouldn't have needed to put break after 2 because 2 was the last case. Or at least after case 2's logic. I didn't need a break at the very end, but I put it just because. Especially if we add another case and then we get follow through from case 2 to case whatever. Uh-oh. It's just saving time in the future probably. Cool. Wait, man, this is a good rocking method right here. Just feels comfy. Rocking in an office chair makes it so much more comfortable. But a recliner is cool just to sit still. But I like moving around like this when I'm reading at least. If I'm locking in and playing games, I'm not moving at all. But I'm taking in information. And notice that when I'm typing, I'm not fucking rocking when I'm typing like a damn psychopath. I'm not on meth, yo. I ain't never done a drug in my life, yo. Trailing comma after last is optional. Yeah. Okay. Hold. It is most common to define one enumerator per line. Oh, if it's like bop bop bop, just to make it easy. Ah, man, fuck off with your damn. Dude, maybe there's gonna be 400 later. Maybe we have more colors. We discover something else, and now all of a sudden I have to space out my lines. Do it now. Type definition for color and its readability too. The type definition for color ends in a semicolon. Yep. Excuse me. All right. We've now fully defined what enumerated type color is. Yes, sir. Cool. Yep. Apple. Sure. Wait, what? Oh, I've typed color. Apple gets red. I was like, color apple. Hello? Retarded? I'm retarded. That's always the answer. Sure is initialized with color green. Cup has blue. Memory is allocated for each because these are fucking objects, mate. How big is the Nina? No. No idea. Note that the initializer for an enumerated type must be one of the defined enumerators for the type. The variable socks and hat. Yep, because white and 2 are not enumerators. Yes. Implicitly const expression. Oh, cool. I don't know what the fuck they are yet, but they are. That's those. They're the values. The enumeration is the program type. The enumerator is the value. Cool. Enumeration, enumerator. Why it's called that? Don't fucking know. Enumerated type is for psychopaths. Yeah, why would you have it be unnamed? Wait, what? An enumeration is like a boolean, like I said earlier, where it has true and false. And it's a boolean. That way I can create a, let's say we call one, it's a tomfoolean. That's the enum, tomfoolean. And tomfoolean has 3 different kinds of pranks on it, because it's for tomfoolery. And then I create a variable of type, of an enum type, which is a tomfoolean Jeff, and he's a prankster, and he does this prank. So he just type whatever, this one. Capital letter, yep. Cool. Numerators must. Well, yeah, because otherwise they don't fucking exist, yo. Unfortunately, there's no common naming convention. That's cool, bro. Lowercase, red, starting with caps, and all caps. Yeah, that's fucking crazy. That's insane. Or prefix with a K and intercap. K, color red. Why? Why? All caps is crazy. Yeah, what? Just do. Oh, good, thank God. Enumerated type with the capital, like regular for program defined types. Enumerated for the lower. Thank God. Good job, man. These people are fucking Bayzed. Enumerated types are distinct types. Each enumerated type you create is considered to be a distinct type, meaning it can distinguish it from other types. Gotcha. Each enumerated type, because an enumerated type is the enumerator, or sorry, is the enumeration. So this is one and this is another. These are not the enumerated types. These are. Cool. Which are considered non-distinct from the types they hold on. Can distinguish it from the other types. Unlike typed Fs and type aliases. Gotcha. Non-distinct. Yes, so enums are literally their own types. It's a distinct type, just like a boolean is from an int. They can't be used as objects of another. Yeah, makes sense. Pet and color. Yeah, sure. If I make a pet and I try and get it black. Oh, well, there it is. A black pet and a cat color. Color shirt pig? No, sir, buddy. Pig is not color. I'm curious of the error, though. Will it say, did you mean to use this enum? Or will it just say, a value of this cannot be used with the enum of this? Let's try and do this eyes closed. Int main. We'll do enum card. Queen. King. Jack. Joker. Ace. I think this is the line. This is the next line. So this has to be the line. This is after the colon. So we're going to have another line and another enum. And it's called bullet. And it has the different types of fuck. What do we just say? We say I can't do the numbers though. Damn it. 762 by 39. Oh no. Let's do 9 by 18. 9 by 19. Oops. Fuck, I don't know if I need another backspace or not. We'll find out. Hot 9 by 39. Quote. We should be on the brace line. after it, or now I'm at the right side of it. Now another line and a blank line. And I think I'm on the line before main or the line between that. We should be on the main line, the quote or the brace line, the next empty line. Tab it out just in case. And we're gonna make a bullet called my bullet, and it gets 9 by 19. Oh no. Oh, wait! It's basically it! I was close, I just accidentally pressed enter there. That was pretty good. I don't know how I messed all this other stuff up, but I was missing the end brace. That's okay. I could be a blind programmer. This is not bad. Well, yeah, we're not using my bullet yet, but it's fine. And then we could also have my card, and it's king. All right. Cool. And we're not using them yet, but it's fine. All right, no break at all. We're going straight until 6 o'clock. So I'm going over to the self-test section right now. So I'm going to end this, upload this, and then start. Cool, that's some enum action. Okie doke. Oh wait, hold it. King is a value. 9 by 19 is a value. Ooh, cannot be used. A value of type card cannot be used to initialize an entity of type bullet. And a bullet cannot be used to initialize an entity of type card. That is cool. What about if we do 3? A value of type int. I like that. So they are treated as distinct types. Yeah, makes sense. Seems like it. Yeah. Enumerated types are distinct types. Okie dokie. I believe you. All right, we're done.